If you've ever built a web app, you know there's this kind of awkward gap between your code and your database. Today, we're going to pull back the curtain on Django's brilliant solution for this. It's Object-Relational Mapper, or ORM for short.
Right. This is the core of the problem. You've got Python on one side, all neat and object-oriented, and then you have your database on the other side, thinking in tables, rows, and the very strict language of SQL. They come from totally different worlds. So how in the world do you get them to talk to each other without writing a mountain of messy, bug-prone translation code?
And this slide right here, this is the perfect picture of that problem. It's what people call the object-relational impedance mismatch. Fancy term, right? But all it means is that the simple Python class on the left and the SQL command on the right are trying to do the same thing, but they're speaking completely different languages. The Django ORM is the magic that acts as the universal translator between them.
So to really get how this all clicks together, we're going to walk through 5 main ideas. We'll kick things off with the ORM's basic job as a translator, then we'll dive into models, the genius behind lazy query sets, some really powerful advanced queries, and wrap it all up with the super important stuff, performance and security.
First up, the bridge itself. You should really think of the ORM as your own personal expert translator. It's built on a design pattern called active record. Now, what that means in simple terms is that every Python object you create isn't just a dumb bucket of data. No, it's active. It represents a single row in your database, and it actually knows how to save itself, update itself, and even delete itself.
So the main takeaway is this. An ORM is a layer of abstraction. It lets you and me work with our data using the Python code we already know and love, and it handles all the messy SQL generation behind the scenes. This is a game changer. It makes development way faster, your code is a lot easier to read and maintain, and as we're about to see, it's a massive shield against some common security threats.
Okay, so how does this bridge actually get built? Well, in the Django world, everything, and I mean everything, starts with the model. A Django model is just a Python class, but it's a special one. It acts as the single absolute source of truth for how your data is structured. It's literally the blueprint for your database tables.
And this is where that abstraction really starts to feel real. When you define a field in your model, like a char field, you're just telling Django, hey, I need to store some text here. The ORM takes it from there, automatically translating it into the right kind of varchar column in your database. It handles all the nitty-gritty details so you don't have to.
And for when you need a little more control, your models can have an inner class called meta. This is where you can tweak things that apply to the whole model, not just one field. You can set a custom table name, for example, or tell Django how you want the data to be sorted by default. It's like the fine-tuning dial for your data blueprint.
Now we get to query sets, which is honestly maybe the most brilliant part of the whole Django ORM. A query set is basically a list of objects from your database, but here's the kicker. It's lazy. It lets you build up and refine this really complex question for your database, but it doesn't actually ask the question until the last possible second.
This quote just nails it. Laziness here isn't a bug, it's the entire point. It's a massive performance optimization. By waiting to actually run the query, the ORM can look at everything you've asked for and figure out the most efficient way to get it all in one single trip to the database.
Let's just follow one of these lazy queries on its journey. Step 1, we ask for all the posts. Step 2, we filter for just the published ones. Step 3, we sort them by date. Now here's the crazy part. Through all of that, we haven't touched the database at all. 0 times. We've just been building a plan. It's only on step 5, when we finally say, okay, give me the first item, that the ORM goes, all right, time to work, builds the perfect SQL, and hits the database exactly 1 time.
So, what are those triggers? When does the query set finally wake up and do its job? Well, it happens anytime you do something that forces it to produce actual results. Things like looping over it, asking for its length, turning it into a list, or, like we just saw, grabbing a specific item from it. That's when the magic happens.
Simple filters are great, but let's be real. The real world is messy. Applications need complex logic, and that's where Django gives you some amazing tools to write incredibly sophisticated queries, all without ever dropping down to raw SQL.
So by default, if you chain a bunch of filters together, you're saying you want results that match this and that. But what if you need results that match this or that? Well, that's what Q objects are for. You can see on the right, we can find users who are either staff members or super users. It unlocks all this complex logic right inside your Python code. Okay, here's a classic web developer nightmare. You need to decrease the number of items in stock. What happens if two people click buy at the exact same moment? They both read the stock as 5, they both calculate that 4 is the new value, and they both save 4 to the database. You just sold an item you didn't have. That's a race condition, and it's bad news.
The solution is so elegant. F expressions. Instead of culling the value out of the database to do the math in Python, an F expression builds a SQL query that tells the database itself to do the math. The whole read, subtract, write operation happens right on the database in one atomic step, which completely vaporizes the race condition. It's so cool. Lastly, for advanced queries, let's talk about summarizing data. You've got two main tools: aggregate and annotate. The easiest way to think about it is this. Aggregate gives you one final number for the entire set, like the average price of all your books. Annotate, on the other hand, adds a new piece of calculated info to every single item in the set, like giving each author a count of how many books they've written. Aggregate summarizes, annotate enriches.
You know, an ORM is so much more than just a tool for asking questions. It's a complete system for managing your data. And that means it has to care about performance, about how your database schema changes over time, and most critically, about security.
I want you to look at this number, 101. That is a terrifying number. It represents the infamous N+1 query problem. Imagine you ask for 100 blog posts. That's query number 1. Then you loop through them, and for each and every post, you make another query to get the author's name. That's 100 more queries. 1 plus 100, 101 database hits for what should be a simple page. And here's the fix. On the left is the code that creates that 101 query disaster. But on the right, look at that one little addition, .select_related author. That tells the ORM, hey, be smart about this. When you go get the posts, grab their authors too, all at once. The result is just stunning. You go from 101 queries all the way down to just one.
So what happens when your app evolves and you need to change your database structure? Django's got you covered with migrations. When you change your models, Django automatically generates a little file that describes that change. It's basically version control, like Git, but for your database schema. It's incredibly safe and reliable.
Now this might be the single most important job of any ORM, keeping you safe. It protects you from one of the oldest, scariest attacks on the web, SQL injection. It does this using a technique called parameterization. Basically, it sends the query structure and your user's data to the database in two separate packages. This makes it impossible for the database to ever mistake user input for a command it should run. It's a huge security win, and you get it for free.
So to put it all in perspective, Django's ORM uses that active record pattern we talked about, which is all about making development fast and intuitive. That's a bit different from other popular tools like SQLAlchemy, which use a data mapper pattern. That approach gives you a ton more flexibility, but it's also a bit harder to learn. It really comes down to a different philosophy. Django values convention, while SQLAlchemy values configuration.
Which brings us to a final interesting thought. The Django ORM is powerful, it's safe, it's incredibly efficient for almost everything you'll ever need to do, but it's not a silver bullet. So the question I want to leave you with is, with all this incredible power, when do you hit the limits? When does a problem get so complex or the performance needs so extreme that you have to use the escape hatch and write raw SQL yourself? Something to think about. Thanks for tuning in.